Hey, what's up guys? This is the video for section 7.3, which is rational exponents. And we are going to look at exponents as fractions. That's why we use the word rational, and that's what it is. It's a fraction. When you guys start looking at exponent as a fraction, you are looking at a specific root. So let's explain let's understand what is the nth root first, and then we can move on to rational exponents. So the nth root is when you start with a square root, the regular one you guys learned in junior high and elementary. But now you guys will move up to a different root. So I give you guys a table on the screen that you guys see, and it has different roots that you guys can find. So the first one is the regular one that you know, the square root. Well, what is the square root? You guys know the symbol right here, which is the radical. And when you take the square root of a number, the concept is you're looking for a number that you multiply by itself. That's going to give you guys the number inside of the radical. So for example, if you look at the square root of 16, the square root of 16 is 4, because if you multiply 4 times 4 by itself 2 times, it gives you guys 16. Or you can say 4 squared, there's the squared, and you guys have 16. So the square root of 16 is 4. That number, 4, multiplied by itself 2 times is 16. That's why we multiply it 2 times, because we want the square root. Square means 2. But now you guys have different roots. So I'm going to look at the cube roots, the 4 roots, the 5th roots, the 6th roots, and so on and so on and so on. So what is the cube root, 4th root, and so forth? Cube root, some people say the 3rd root, is when you guys have the radical, just like the square root, but we have a little number outside of the radical, in between the tail of the radical, and there's a 3. So this cube root means that you are looking for a number that you multiply by itself 3 times, and it gives you guys the radicand. So let's look at an example that I have here. The 3rd root of 27, so I have the little 3 outside and the radical, so I don't say the square root, now I say the 3rd root, and the radicand is 27. So I need to find a number that you multiply by itself 3 times. And if you look at the screen, 3 times 3 times 3, that's 3 times, and that's going to give you guys 27. 3 times 3 is 9, 9 times 3 is 27. So this number, 3 cubed, which is the same thing as 3 times 3 times 3, is the cube root of 27. So the cube root of 27 is 3. So notice that we have the little 3, which means cube root. Now we have something else. We have the 4th root. The 4th root, same concept. You guys have a little 4 outside, but now you're looking for a number that you multiply by itself 4 times, and it will give you guys the number inside. So I have an example right here, the 4th root of 16. So if you think about it, just look for numbers. What number do you multiply by itself and 4 times, and it's going to give you guys 16? Well, if you take 2 times 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and that's what we want. And if you count the number of 2's, 1, 2, 3, 4. So this 4th root, I'm going to put a little 4 outside of the radical. Notice it's in between the tail and the radical. And you take 2 to the 4th power, which is 2 multiplied by itself 4 times. That's going to be your root. So the root, the 4th root of 16 is 2. So let me write down the 2. And I'm going to put a 2 right here. So my answer is 2. Notice that it's very different if I ask you guys what is the square root of 16. Square root of 16, you guys can see it over here, is 4. Square root of 16 is 4. But the 4th root of 16 is now 4, is 2. Because you're looking for that number that you multiply by itself 4 times. And those little numbers outside, they tell you guys how many times you have to multiply the number by itself. Now we also have the 5th root, the 6th root, the 7th root, and so forth. So I give you guys an example here for the 5th root. And the 5th root of 32, well, what number do you multiply by itself 5 times? That's the 5th root. 2 times 2 times 2 times 2 times 2, that's 5 times. You see the exponent of 5, 2 to the 5th power. Well, the 5th root of 32 is 2 right here. Something else you also have to know, and it's going to help you guys a lot in the future, is the radical is actually the opposite of the exponent. So if the exponent and the radical, the roots are the same, so notice we have the 5th root and exponent of 5, they actually cancel each other. They're opposites from each other. So you can cancel the first root and exponent of 5, and all you have left is 2. Over here, you can cancel the cube root and the exponent of 3, and all you have left is 3. So that's one of the things that we can use in the future when we solve radicals. Now, the next step. Now that you know what is a cube root, fourth root, let's look at the definition here. When you look at the nth root, which means the third, fourth, fifth, sixth, seventh, eighth, ninth, 10, and you can keep going to infinity, you guys can write it as a fraction. So when you look at the radical, let's look at the fourth root here. So the radical has a little 4 outside, so this means the fourth root of the number. You can write it as an exponent in fraction form, and that's exponential form. Okay, you guys have a rational exponent. Rational means fraction. So the 4 is going to go on the bottom of the fraction. If you have the cube root, the 3 is going to go on the bottom of the fraction. If you have a square root, well, you don't see a number here, but mathematically, guys, there's an invisible 2 outside of the square root. No one sees it, no one uses it, because everyone knows that if there's no number outside of the radical, it's just a square root. But you guys write it as an exponent of 1/2. So the exponent of 1/2 means square root, the 1/3 cube root, 1/4 fourth root. So if I put a 5 here, that's the fifth root. If I put a 6 here, sixth root, 7, seventh root, 8, eighth root, and so forth, and so forth, and so forth, and so forth. So that is what a rational exponent is. Your exponent is a fraction, but the denominator tells you guys the root that we're looking for. So first, let's go ahead and get used to writing from exponential exponents to radicals with the square root or maybe the third root in an expression. So let's go and look at some examples. All right, so let's go ahead and look at these expressions here, and you want to change them either to radical or exponential form. So first, let's look at exponential form, and you guys notice that we have an exponent, and it is a fraction, so 1/2 exponent, 1/2 exponent, and we have to know that the exponent of 1/2 means the square root. So you want to write, you're not looking for the actual answer, you guys can, but we only want to write it as a radical form. So if we look at the first one, we have 25 to the 1/2 power. All you have to do is, first, you take the square root. So the 1/2 turn into a radical, so that is the square root. I don't need the little 2 outside because by default, there's an imaginary invisible 2 there, so you don't need to put it. And you put the number 25 inside of the radical. So 25 to the 1/2 power is the square root of 25. Again, the answer is 5, the square root of 25, but you don't need to find the answer here. You just want to write it in radical form. Now, the next one, you guys have a 49p to the 1/2 power. First, let's understand what these two things are happening or are doing to each other here. When you guys don't have anything in the middle, the 49 and the p, you actually are multiplying. By default, you have a multiplication sign and it is invisible. So when you guys actually separate the 49 and the p, the 49 has an exponent of 1, not 1/2. So I'm going to put a 1 here. And what that means is only the ones that have the exponent of 1/2 goes inside of the radical, the square root. And the only thing that has a 1/2 power or exponent is p. So you guys will have your radical here. P goes inside, but the 49 is going to go outside because it has an exponent of 1. So you don't need the radical around the 49. So this is your radical form. Now the next one is a little bit different because you guys have parentheses with the 7w inside. Notice the difference between this one, no parentheses, and this one with parentheses. Now the idea for this one here is if you guys actually use the properties of exponents, remember that 7 has an invisible 1 exponent, w has an invisible 1, you can multiply the exponents. Now we do have a 1/2, but you guys can actually multiply 1 times 1/2. So we have 7, 1 times 1/2 is 1/2, and w, 1 times 1/2 is 1/2. So notice the 7 has a 1/2 exponent, and the w has an exponent of 1/2. So what that means is when you guys have your square roots, you are going to have the 7 and the w inside of the radical. So be careful with that difference there when you guys have parentheses. So anything inside of the parentheses is going to go inside of the radical. And this is your square root because we have 1/2. The 2 on the bottom is the root. Now let's go ahead and do the opposite. If you guys want to write a radical, so all of these are radical form because you guys have a square root, you want it in exponential form. So first you need to know what exponent you need. And notice all of them have a square root. So we need an exponent of 1/2. So anything that goes inside of the radical, so you are going to take the number inside of the radical, which is the radicand, that's the name of the number. So I do have a 41 here, and I'm going to use an exponent of 1/2. So the square root of 41 is the same thing as 41 to the 1/2 power. And that's what we want. So now you go to the next one and you look at what we have here, the square root of 5m and p. Notice everything here is inside of the radical. So you guys would need to use parentheses with an exponent of 1/2 because I have more than one number. I have more than one variable inside of the radical. So I'm going to use parentheses here, and my exponent is going to be 1/2. So the 1/2 means the square root. And everything inside of the radical is going to go inside of the parentheses. So that means that everything is raised to the 1/2 power. The 5 will have the 1/2 power m 1/2, n 1/2, p 1/2. And everything, since it has a 1/2, it needs to be inside of the radical. So that is my exponential form. If you guys have a number outside, that don't get confused, this number is not in between the tail and the radical, so this is not the cube root. We have 3 times the square root of xy. So 3 is outside of the radical. Xy are inside of the radical. So we need parentheses because we have more than one thing inside of the radical, which is the x and the y right here, x and the y. And those go inside of the parentheses with the exponent of 1/2 because they are inside of the radical. The 3 stays outside because it's not inside of the radical, it's outside. So you put the 3 outside of the parentheses, xy to the 1/2 power. If you guys distribute, remember you can multiply the exponents. The x will have exponent of 1/2, y will have an exponent of 1/2, and since they both have exponent of 1/2, they go inside of the radical. 3 has an exponent of 1 here. So my radical form is here. Now you guys are ready to actually simplify when you guys have square roots or third roots or fourth roots and so forth. Now you guys can actually use a calculator to simplify, but I'm going to show you guys how to do this by hand, and then in class I'll show you guys how to use the calculator. Every calculator is different, so every brand has a different button and the way they do square roots and radicals and all that. It's a little bit different, so make sure you guys know your calculator. Just try playing with numbers and get used to your calculator. But let's go ahead and do this without a calculator. So first, we need to understand what we are looking for. So here I have 125 to the 1/3 power. That means I'm looking at the bottom of the fraction, and is a 3. So we have the third root. So let me just zoom in here, and we want to simplify. First, I'm going to just rewrite it as a radical form. Remember, radical is when you just use a radical. So if I know this is my root, third root, I'm going to need a radical here with a little 3, small 3 outside of the radical. And notice it's in between the radical tail and the radical, so there's the 3. This one here means you guys have the third root. And inside of the radical, you guys have the number 125. So that's your base, which now is a radicand, is inside of the radical. The idea of the third root is you want to find a number that you multiply by itself 3 times 3 because you guys have the third root, and it's going to give you guys 125. So we can do prime factorizations just like square roots. You guys break down the number. So I know that 5 times 25 is 125. I can break down the 25. 5 times 5 is 25. Now the 5 is prime, so you guys cannot break it down. But I'm going to start making groups of 3s because I'm looking for the third root. If you're looking for the square root, you look for groups of 2s or pairs. If you look for the fourth root, you have to make groups of 4. So if you are able to make a group, that number is going to go outside of the radical. So I look at the 5 here. That's 1, 2, 3. So notice I do have a group of 3s, and I have 5. 3 5s. So that means that the 5 goes outside of the radical, and that is the cube root of 125. And if you guys check, you can also multiply 5 by itself 5 times. I'm just going to show you here on the side. If you take 5 times 5 times 5, 3 times, because this is the third root, 5 times 5 is 25, and 25 times 5 is 125. So that's the idea when you guys break down the number. If you have the fourth root, notice here my denominator is 4, so I'm looking for the fourth root. I'm going to have my radical. I'm going to change this to radical form. So here's my radical, and my root is 4, so I put a 4 outside of the radical, in between the tail and the radical. My base will become the radicand, so 256. Now you guys are going to start breaking down the number, and this is where you do prime factorization, and notice that the number is even, so I can multiply 2 times some number that gives us 256, and that's going to be 2 times 128. Now you guys can also break down the 128. So that's going to be, it's even, so I know 2 goes into it, so 2 times 64. If you guys look at the 64, oh, that's going to be 8 times 8. And you guys keep going. You guys break down the numbers. The 8, you can have 4 times 2. And the 8 over here, 4 times 2. And then the 4 here, 2 times 2. And over here, 2 times 2. Now, remember that we are looking for groups. Let me just zoom out so you can see groups of 4, because we had the fourth root. So I'm going to start making my groups. I'm going to start with the 2 here. 1, 2, 3, 4. So that means that I can put a number 2 outside of the radical. So let me just put the radical here. There's the fourth root. There's the 2 outside. But I have more numbers. So let's see if I can make another group of 4. So I keep going. This is 1, 2, 3, 4. So that's another group of 2's, and it's groups of 4. So I put another number outside of the radical, and I'm going to multiply the 2 that it's already outside. Now, do we have any more numbers? No. So that means that you guys do not have anything inside of the radical. So I'm just going to erase the radical here, and I do multiply 2 times 2, which is 4. So the fourth root of 256 is 4. Now again, you guys can check. If you multiply 4 times 4 times 4 times 4, 4 times, because we found the fourth root. And let me just write that down so you guys can see it. If you actually multiply 4 times 4 times 4 times 4, that's going to be 256. And that's how you check if you get the right answer. But to break it down, you just want to find groups of 4. The next one, we have the fifth root. So I know we have the fifth root because we have the little 5 outside of the radical, and it's in between the tail and the radicand. Now this one, yeah, it is a big number, but you guys just start breaking down, and I always try to find what numbers go into that number. So it's even. I know it's even because it ends with the 4. Any number that ends with the 4, a 2, a 4, a 6, an 8, a 0, it's even. So I know that 2 times 512. Now 512, it's also even, so 2 times 256, and 256, again, it's even, so I have 2 times 128, and the 128 is 2 times 64, and it's a little bit of work, but you guys start breaking down the numbers. 64 is 8 times 8, and the 8 is 4 times 2. 4 times 2, and the 4 is 2 times 2, and the 4 over here is 2 times 2. So let me just zoom out a little bit more so you guys can see the whole picture. And then now you guys start making groups of 5 because we have the fifth root. So let's see if we can make groups. If you guys cannot make groups of 5, that means the number will stay inside of the radical. But the groups of 5, the number that you guys can make a group of 5 goes outside of the radical. So I do have 1 up here, 2 2s, 3 2s, 4, and 5. So that means you're going to take that number outside of the radical. So let me just put the radical here, and you put a 2 outside because we made a group. Now let's see if we can make another group. So I go here, 1, 2, 3, 4, and 5. So I can make another group of 5. So that means you guys put the 2 outside and you multiply by the other number that's already outside of the radical. We don't have anything else to make groups or we don't have numbers that don't have a group of 5. That is not a group of 5. So once again, that means that we don't need the radical. And 2 times 2 is 4. So the question is, what is the fifth root of 1024? Well, the answer is 4 right here. And now in this one, if you multiply this by itself 5 times, that's the root, fifth root. 4 times 4 times 4 times 4 times 4, 5 times, you guys will get 1024. That's how you check. Now this one here, you guys actually have a fraction. You guys have an exponent outside. So first we're going to use the property of exponents where you guys have to multiply the exponents, the one outside of the parentheses times the ones inside. So the 32 has an exponent of 1, 3125 has an exponent of 1. I'm going to multiply and multiply down here. So I'm going to have 32 to the 1/5 power, and over here 3125 to the 1/5 power. I'm going to change that to radical form because I like to see the radical and I need to know what root I'm looking for. So I do have a denominator of 5, so I'm looking for the fifth root. So that means that we have a little 5 outside of the radical, and there's a 32 on the top, inside the radical, and then I have the fifth root, 3125 over here. Now you guys are going to start breaking down the numbers. Now remember that this is without a calculator. With the calculator, you guys can plug in the numbers, you find this, the fifth root, and it gives you guys the actual answer. Or you can actually use exponents of 1/5. But if you guys take the number 32 here and you're looking for the fifth root, so let's go ahead and break it down. 32, that's 8 times 4. 8 is 4 times 2. 4 is 2 times 2. And 4 here is 2 times 2. And I'm going to make groups of 5. 1, 2, 3, 4, 5. Hey, so guess what? The fifth root of 32 is 2 because we are able to make a group of 5. 2's. So 1, 2, 3, 4, 5. So you don't need the radical because we don't have anything else to put it inside of the radical. Now the bottom number is 3125. So it ends with the 5. So that means that 5 goes into, so 5 times some number, and that's 625. And then we can break down the 625, 5 times 125, and you guys can also break down 125, that's 5 times 25, and 25 is 5 times 5. So let's see how many groups we have, or how many numbers we have, and hopefully we make a group of 5. So there's 1, 2, 3, 4, 5. So we are able to make a group of 5. So that means that the fifth root of 3125 is 5. Now check, double check. We have a fraction, no more radical. Can we simplify the fraction? 2 over 5? No. So my answer is 2 over 5. All right, guys, so now we're going to start simplifying radicals when you guys have exponents inside and variables inside of the radical. So make sure you guys also understand what roots we're looking for because that's how many groups we need to make. So the third root, fourth root, fifth root, or the square root, that means 2. So just be careful with the roots. And I'm going to look at the first one here. You guys notice that all the radicals, all the roots, they do have variables and exponents inside. Last video on radicals in section 10.2, I show you guys that you can expand the variables and you start making groups of 2's. Now here's the thing. When the exponent is large, well, you don't really have to expand. I'm going to show you guys a shortcut that you can use in order to find the exponent that you need inside of the radical and outside of the radical. So first, let's understand what we have. We have the third root of 27, a to the 5th, b to the 8th, c to the 9th. So we want to find a number that you multiply by itself 3 times. There's the third root, so 3 times that gives you 27. And then I'll show you guys how to simplify this when you find the third root. So first, let's go ahead and break down the 27. We want to break it down because we are going to look for those groups of 3's because we have the third root. So 9 times 3 is 27, and 3 times 3 is 9. So if you look, 1, 2, 3. So that means that we can take out a 3 because we have a group of 3's. So my radical, let me put the third root right here. That's my radical. 3 goes outside. And notice that I'm leaving space here because I'm going to have to put some variables. I have a, b, c, maybe outside of the radical. So now, how do you simplify a to the 5th power and you're looking for the third root? Well, let me just underline what we're working with here, a. So when you take the exponent of the a is 5. And this is a shortcut you guys can use. Instead of expanding a times a times a times a times a, you guys can divide the exponent of the a. And I'm going to do the work on the side. So I'm going to take 5 and I'm going to divide by the root. And we do have the third root right here. So I'm going to do the long division, just like elementary. 3 goes into 5 one time. I multiply and I subtract the numbers. 5 minus 3 is 2. Now my remainder, this one here, is the exponent you guys will use inside of the parentheses for the a. And the top number is the exponent you guys will use outside of the radical for the a. So what do I mean? Here's an a outside, here's an a inside. So the a outside is going to have exponent of 1 because that's the top number. And the a inside is going to have exponent of 2 because that's the remainder, 2. So a to the first, a squared. Then you guys move on to the next one. b. b has an exponent of 8. So I'm going to do the little division here. 8 divided by 3. So 3 goes into 8 2 times. That's going to be 6. And then you subtract 8 minus 6 is 2. So this remainder is inside. That's the exponent inside of the radical. And this one is the one outside. So you guys will have b. And I'm going to have an exponent of 2 outside. B inside with an exponent of 2 because we have remainder of 2 and the number is 2 on the top. And finally, you guys move on to C. So C has an exponent of 9. So once again, you do the little division here, 9, and then you divide by 3. So you guys have 3 goes into 9 3 times. So that'll be 9, and remainder is 0. So that means, guys, inside of the radical, you're not going to have a C because C to the 0 power is 1. So you don't need that. You don't need that one. So you don't have anything inside, no C inside of the radical, but outside of the radical, you guys have a 3. So we have a C to the 3rd power, and there's no C inside. And that's my answer. Now, you guys don't need the exponent of 1 here for the A, so you don't need it, but we have 3ab squared c cubed times the cube root of a squared times b squared. Now, let me give you guys another example when the exponent is smaller than the root. Imagine if you guys have a to the 2nd power, 2 is smaller than 3. So that means that 3 doesn't go into 2. So all you do, guys, you keep the 2a squared inside of the radical. You only divide when 3 or the root goes into the exponent. So if you guys have an a squared here, then you just leave the a squared inside of the radical because 3 doesn't go into 2. Or even if you have the fourth root, but you have an exponent of 2, well, 4 doesn't go into 2, so you leave the squared inside of the radical, okay? So let's try the next one here. The next one, we have the fourth root. So first, let's break down the number. I know that 9 times 9 is 81. 3 times 3 is 9. 3 times 3 is 9. I can make a group of 4. 1, 2, 3, 4. So I can take out the fourth root, the number 3, outside of the radical because there's a group of 4, so take out the 3. And then you guys are going to divide the exponents. So I'm going to do the x first. There's an exponent of 8. So I have 8 divided by the root, and the root is 4. So I put 4 outside. So 4 goes into 8 2 times. So that's going to be 8. 2 times 4 is 8. Remainder is 0. So this one here is inside. So we don't have x inside. And this is outside. So I have x squared outside, but there's no x inside. And then you guys go to the next one, the y. So now you guys do 5. That's the exponent of the y. Divided by 4. So that's 1 time. 1 times 4 is 4. And the remainder is 1. So this one here is inside, and this one here is outside. So we have y to the first power, and inside we do have a y to the first power. And then you guys move on to the z's, and the exponent is 7. So 7 divided by 4. Well, 4 goes into 7 1 time. So that's 4, and the remainder is 3. So this one is inside, and this one is outside. So you guys will have a z with exponent of 1 outside, and z with an exponent of 3 inside. Now once again, guys, you don't need the exponent of 1 here. So let me just rewrite it. 3x squared yz times the fourth root of yz cubed. The y inside has an exponent of 1. You don't need it. So there's my answer. And the last one I'm going to do here, guys, is when you have the exponent, not the exponent, the root is 5, the fifth root. So we do the same idea. First, let's go ahead and break down the numbers. So 8 times 4 is 32. 4 times 2 is 8. 2 times 2 is 4. And over here, 2 times 2 is also 4. So let me see. I have 1, 2, 3, 4, 5. Hey, so we can take out a 2 from the radical. So here's the fifth root, and I have a 2 outside. Now I go to the p's, and the p has an exponent of 7. So I do 7 divided by the root. The root is 5. You guys know here, that's the root. And that's going to be 1 time. So my remainder is 2. So that means that we have, this one goes inside, and this one goes outside. So we're going to have a p to the first power inside, and a p to the second power inside. So p to the first power outside, and p to the second power, p to the first power outside, and p to the second power inside. And then you guys go to the q's. So q, the exponent is 5. So I take 5 divided by 5, so that's 1. So the remainder is 0. So that means you don't have q's inside, but you guys will have a q with the first power outside. And then you guys go to the r's. Exponent is 7. So 7 divided by 5, that's 1. And the remainder is 2. So this, you guys will have r to the first power outside, r to the second power inside. Remember, the bottom number goes inside and the top number goes outside. And those are the exponents you guys will use. All right, so you don't need those exponent ones. So I'm going to have 2pqr times the fifth root of p squared r squared. So guys, I'm going to have to do a second part of this section, second video. So make sure you guys check that out when I upload it to YouTube. And make sure you guys practice your math, and I'll see you guys later.